So in the last class, we were discussing about how to represent organic molecules, right? We have discussed about the many formulas, skeletal formula, displayed formula, 3D formula. Okay. So here there are two ways of representing benzene molecule. Benzene is your aromatic compound. It is C6H6. Okay. So this is a displayed formula. In displayed formula, you have to display all the bonds. Okay. Why it is circular inside? Because you know that benzene we can make like this also, and benzene we can make like this also. Both are same. Both are same. Because here what happens? Delocalization of electrons will happen. Okay, this bond can move to here, this will move to here, and this will move to here. So there is a delocalization of electrons which is going on. That's why overall we represent it as a circle. Circle means that electrons are moving here and there in all these bonds. Okay, so skeletal formula is this. Skeletal formula in which we are not going to show the carbon, not going to show the carbon and hydrogen bonds. Okay, we are only showing the double bonds. This is the skeletal formula, or this is also the skeletal formula. And displayed formula is this, when you are displaying all the bonds. This is your displayed formula. So these are the ways of representing benzene. In benzene, electron density is not fixed at a particular position. It is delocalized. Delocalization of electron means it is moving. Electron density is moving here and then here and then here to satisfy the valency of carbon.
I'm done.
Here, this is the formula of methyl benzene. This is the formula of 1,2-dimethyl benzene. This group, CH3 group, is known as methyl, so it is methyl benzene. This is 1,2-methyl dimethyl because there are two methyl groups. That's why we write dimethyl benzene. This is 1, this is 2. And this is what? 1,4. 1, 2, 3, 4. So it is what? 1,4-dimethyl benzene. If only one alkyl group is bonded to a benzene ring, so we do not have to include a number in its name. For example, here we have written 1-methyl benzene because there is only one group. If you write, then also it is methyl benzene. If you write CH3 in this position, then also it's methyl benzene. When there is only one alkyl group, so you do not need to write the number in its name. This is because all the 6 carbon atoms in the rings are equivalent. So if you write like this, so counting will start from here. If you write like this, then the counting will start from here only. So it is equivalent. All the carbon atoms are equivalent. No functional group is there. That's why we write it like this only. Methyl benzene. Hello, Alicia. Welcome to the session. Am I audible?
Hello, ma'am. Yes, you're audible. I was just having a connection problem.
Okay,
I think my camera will have to be off.
Okay, no problem. Here what we are discussing, let me tell you, we are discussing about the ways of representing benzene. There are two methods of representing benzene. One is by the displayed formula in which we are displaying all the bonds of carbon. We are showing carbon, we are displaying all the bonds of carbon, carbon and carbon hydrogen. We discussed about the displayed formula in the last classes. And about the skeletal formula in which we are not displaying carbon, not displaying carbon hydrogen bonds. Okay, and what is this circle inside this benzene ring? It means double bonds. Because benzene, it can be made like this, it can be made like this. Electrons are delocalized in the benzene ring. This electron density, it can move to here, this can move to here, this can move to here. So these are your reversible structures. That's why we make it like a circle. That means electron density is revolving inside the benzene ring all around. Is it clear?
Yes.
And then we are discussing about the formulas, how to write the IUPAC name of benzene rings. If you have only one alkyl group, then you do not need to write the number in its name. You write just methyl benzene. If you have two methyl groups at the adjacent position, then you write 1,2 dimethyl benzene. And then you can number if you have 1, 2, 3, 4 dimethyl benzene, and you have to tell me the name of this compound.
Is it 1,3 dimethyl benzene?
Yes, it is 1, 3 dimethyl benzene.
I'm done. I'm also done.
Okay. So for today, this is your homework question. You have to write down the displayed formula of propyl benzene, 1-ethyl 4-methyl benzene, 1,3,5 triethyl benzene. Question number 2 is draw the displayed formula of bromo 3,3 dichlorohexane. Question number 3 is which of the following is the structural formula of the aldehyde 3,5 dimethyl hexane. Okay, these two are your homework questions. Question number 1 and question number 2. Question number 3, you have to solve it now and tell me the correct answer.
Ma'am, the homework is question 1 and 2 or number 3?
Homework is question number 1 and 2. Question number 3, you have to solve it now in the class.
Okay. I'm done.
The answer of question number 3.
I got B.
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 Is your answer, Shama?
Is it?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
C.
Okay, so let us solve B and C. There's confusion in B and C. So let us make the structure of B. CH3, CH. This bracket means that it is in the branching. Okay, bracket means that you have to make it in the branching. Then you have CH2, CH. Then again CH3 is in branching. Then CHO. CHO is made like this. C double bond O and H. So A cannot be the answer because functional group is different. It is carboxylic acid, right? A cannot be the answer because our functional group is aldehyde. So if we want to name this compound, then obviously counting will start from here because functional group lies here. 1, 2, 3, 4, 5. So it should be 2, 4 dimethyl hexanyl. 2, 4 dimethyl, pentanol. There are 5 carbon atoms in the root chain. So it is 2, 4 dimethyl pentanol. So B cannot be the answer. Alicia, please check. In the C part, let us see. CH3, CH. This CH3 is in the branching. Then it is CH2, CH. Again, CH3 is in the branching. Then CH2, CHO. Counting will start from here. 1, 2, 3, 4, 5, 6. Its name should be 3, 5 dimethyl. There are 6 carbon atoms. So hexanol. 3, 5 dimethyl hexanol. And the question is asking 3, 5 dimethyl hexanol only. So option number C is correct. Please make the correction. Option number C is correct. Is it clear, Alicia? Any doubt?
No doubts.
Okay, then tell me the IUPAC name of this B part.
The name for B.
IUPAC name of
Or
this
for
which I am drawing. This one.
three
Hmm?
3-methyl pent.
Counting will start from here now. 1, 2, 3, 4, and 5. It is one and the same thing if you make it like this or you make it like this. It is one and the same thing. Okay, you have to select the first rule is that you have to select the longest carbon chain. What is the longest carbon chain here? 1, 2, 3, 4, and 5, right?
Yes.
Okay, so what should be the name of this compound?
3-methyl pentanol.
So what do you think, Shama? Is it correct? 3-methyl pentanol.
I have a question. Why is CH3 considered as the fifth one? Isn't it a branching?
CH3 is a branching, but if you make it like this, CH2, we are making this D compound, right? In this CH2, we have CH3 as a branching, right? And then we have CH3. Please make the distillate formula of this compound, D part. What should be the distillate formula of this compound? I think there is some mistake. There should be CH2 because the carbon valence is not satisfied. Let me check. Just give me a minute. So let me just clear it, and again we are drawing this. Okay, so draw the distillate formula of this D part. This part. CH3. This CH3 is in the branching. Its valence is satisfied 4. Its valence is also not satisfying C because we have 3 hydrogens, 1, 2, 3, and then it is again CH2. So its valence is not satisfied. So it should be CH2. Then okay, then we make CH2, then again CH3, then CH2, then CHO. One, 2, 3, and 4. Yes. Now tell me the IUPAC name. 1, 2, 3, 4. It is in the branching, but the first rule of IUPAC nomenclature says that we have to select the longest carbon chain. So longest carbon chain is this, right? 1, 2, 3, 4, 5. That's why it is pentanol. The root word is pentane. Okay, there are some IUPAC rules which we have to follow. So here CH3 is in the branching, but no other group is here. No other group is lying here. That's why we have to select for the longest carbon chain. Maybe it is in branching or not. So it doesn't matter. So the root word is pent. Functional group is aldehyde, pentanol, and it should be 3-methyl pentanol. This is the IUPAC name of this compound, 3-methyl pentanol. This is misprinted. It should be CH2. Sorry, it should be CH2. Clear? Okay, then tell me the IUPAC name of this A part also. Should be CH3, CH. You have to see its valency. It is CH. That means carbon valency is now satisfied. CH2, CH, then CH3 again, then CH2, then COH. What should be the IUPAC name of this?
Hexanoic acid.
Hexanoic acid is correct, but what should be the prefixes? It is hexanoic acid, but what should be the prefixes here?
3, 5 dimethyl. 3,
Yes.
5 dimethyl.
3,5-dimethyl hexanoic acid. So here write down one more rule of IUPAC nomenclature that you have to identify the longest carbon chain. identify the longest carbon chain containing the functional group. The functional group should be there in the carbon chain which you are selecting. So in the D part, the longest carbon chain is of 5 carbon atoms. But it should be in continuity. Okay, for example, this is in continuity. Is it clear? Any doubt in this?
No.
No.
Now let us study about the sigma bonds and pi bonds in organic chemistry. Each in carbon chemistry, that is organic chemistry, we have 6 electrons, 6 protons, 6 neutrons. Okay, and the electronic configuration would be 1s2, 2s2, 2p2. It means that carbon has 4 electrons in its outermost shell, because this is my n, which represents your principal quantum number, which represents your energy level. So this carbon atom has 4 electrons, 2 in the s subshell and 2 in the p subshell in the outermost shell. By forming single covalent bonds with 4 other atoms, a carbon atom can gain the electronic configuration of the noble gas neon. Because every element wants to achieve stability, so carbon also achieves stability by attaining the noble gas configuration neon by sharing the 4 electrons with the other atoms. So these single covalent bonds are known as sigma bonds because carbon have 4 of its own, 1, 2, 3, 4, and it shares 4 of the other elements. For example, hydrogen. Hydrogen have one electron. So by sharing of electrons, carbon can complete its octet and becomes stable. So these bonds are known as sigma bonds or single bonds. We represent it by a single line like this.
I'm done.
I'm also done.
Bond angles, they are close to 109.5 degrees in an ethane molecule. The two carbon atoms, each forming 4 sigma bonds, are said to be sp3 hybridized. If you want to make the ethane molecule, ethane is C2H, 2n plus 2, that means 2 into 4 plus 2, which is 6, C2H6. So in making C2H6, you have to make carbon and then 3 hydrogens here. One should be below the plane, which is represented as a dashed line, and one should be above the plane, which is represented as a wedge bond. Similarly, here one should be above the plane, and one should be below the plane, and one should be in the plane. This means it is in the plane. So this is the structure of three-dimensional structure of ethane. Now, if you see the hybridization, of both the carbon atoms are sp3 hybridized. That means one s orbital is involved in making this bond and 3 p orbitals are involved in making this bond. So it is sp3 hybridized. Whenever you have 4 bonds, then always it is sp3 hybridized. 3 from p and 1 from s. So it becomes total of 4 bonds. If I ask you the hybridization of ethene, then what should be the hybridization of carbon atom? How many sigma bond it is making? Because in hybridization only sigma bonds participates, not pi bonds, because pi bonds cannot that much overlap. That's why only sigma bonds will participate. You know that in the double bond we always have one sigma and one pi bond. Okay, so how many sigma bond it have? One sigma of this hydrogen, one sigma of this hydrogen, and one sigma of this double bond. So total we have 3 sigma bonds in ethene. 3 sigma bonds means 1 of S and 2 of P. That means it is sp2 hybridized. If I ask you the hybridization of ethyne, then what should be the hybridization of ethyne? What should be the hybridization of carbon atom in ethyne molecule? So you should know that in triple bonds, we have 1 sigma bond and 2 pi bond. 1 sigma and 2 pi. And this is single bond. In single bond, we always have a sigma. So what should be the hybridization? Total, how many sigma bonds are there which are present in one carbon? 2 sigma bonds are present. 2 sigma bonds means 1 of S and 1 of P. So it is sp hybridized. If you have 4 bonds, then it is sp3 hybridized. If carbon atom makes 3 bonds, it is sp2 hybridized. If carbon atom is making 2 bonds, then it is sp hybridized. I'm talking about sigma bonds, not pi bonds, only sigma bonds. This is a tetrahedral molecule in which always we have this angle 109.5 degree. This is fixed for every tetrahedral molecule.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
I'm done.
Now here you can see that we have overlap of p orbitals. Overlap of two p orbitals results in a pi bond. When you have p orbitals, what is the shape of p orbital? You know what is the shape of p orbital? It is dumbbell shape, right? One, and it have two lobes. So the shape of p orbital is dumbbell shape. It have two lobes. One is positive node and one is negative lobe. So what happens? Overlap of two p orbitals, it results in a pi bond. Carbon is having a vacant p orbital, right? What is the electronic configuration of carbon? It is 1s2, 2s2, 2p2. In the p subshell, how many orbitals we have? Tell me, how many orbitals we have in p subshell? We covered this in the atomic structure chapter. 3 orbitals, right? In the p subshell, we have 3 orbitals. So two are filled and one is empty, one is vacant. So these are my vacant p orbitals. When the overlapping occurs like this, so it forms a pi bond. So how does the pi bond forms? The overlap of two orbitals results in a pi bond. Ethene is described as a planar molecule. So remember that when you are making ethane or methane, so you are writing like this. Two hydrogen are in the plane, one hydrogen is below the plane and one hydrogen is above the plane. So it is not planar. It doesn't lie in a plane. One bond is above the plane and one bond is below the plane. But if I ask you in the ethene, you are drawing ethene like this, not the above the plane and below the plane hydrogen atom. That means it is a planar molecule because it is sp2 hybridized. sp2 hybridized are always planar and sp3 hybridized are non-planar. All the carbon and hydrogen atoms in the ethene molecule lie in the same plane. It is in the plane, no above and no below. The two carbon atoms are said to be sp2 hybridized. So how the pi bonds are forming? When these two orbitals are overlapping, when these two p orbitals are overlapping, so it forms a pi bond. The electron, this is electron density. Okay, so electron density is concentrated in the middle. And here the bond angle is 120. That the bond angle in sp2 hybridization is 120 degree and the bond angle in sp3 hybridization is 109 degrees. Is it 109.5 degrees? Okay, so don't get confused here that it is showing below the plane and it is showing above the plane while it is an ethene, it is planar. Till now, double bond is not formed. It is just overlapping. When overlapping happens, when the p orbitals combine together and when double bond is formed, then these are planar. No above the plane bonds and no below the plane. Now draw it for ethine. Carbon atoms can also form triple covalent bonds, which are alkynes. Simplest alkyne is your ethine. When forming a triple bond, carbon atoms are sp2 hybridized. Sorry, sp hybridized, because there are only two sigma bonds. In a single bond, you have one sigma. In a double bond, you have one sigma, one pi. In a triple bond, you have one sigma and two pi.
I'm done.
I'm also done.
Okay. So tell me the answer of this question. Which molecule is an example of carbon atoms adopting both sp2 and sp3 hybridization? C2H2 is this. C2H4 is this. And C2H6 is this. And C3H6 is this. What should be the answer?
I think it's D.
Yes, D is the correct answer because here we have carbon atom. This hybridization of this carbon atom, tell me.
Which one?
This one. Third one.
The first one.
Yes.
I think it's in a double bond, so it's sp2.
And this one. This second one.
I think that's also sp2.
Yes. And this third one.
sp3.
Yes. So D is the answer. It is an example of carbon atom adopting both sp2 and sp3 hybridization. Because in this we have only sp. In this we have sp2 only. Both carbon atoms have sp2 and both carbon atoms